Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? Everybody okay? Okay, good.
Alhamdulillah.
Alhamdulillah. Okay, today we're going to finish up the elasticity, and then we move on to, remember the second part, the last part of partial derivative. I didn't cover that. I think I will do that. I will do the discussion. So we're going to do the finish up elasticity, and then I will discuss about the Lagrangian multiplier. Lagrangian multiplier is chapter number 14, last part of chapter 14. So that we'll do today. And then I have to discuss with you the midterm also, the midterm exam. Okay. If you recall, we were doing last class. That was this one. We were talking about the elasticity, and we did a few examples. I think, we stopped there, where we compute the value of the elasticity at a given price. Okay, so the P here, the P and Q in the formula, it's the given point, okay, a given point. So you're given the price, then you can find the Q using the demand function. So you got the values of the P and Q, and then we get the slope. So we can determine the price elasticity of demand. And as we know, since the slope is negative, slope of the demand function is negative, the elasticity of demand would be negative. So if the price goes up by 1%, here, 2/3. 2/3, what percent? 2/3 is 2 divided by 3 divided by 0.67%. So it is about 0.67. So what does it mean? It means that if the price goes up by 1%, then what about the demand? The demand will go down by 0.67%. So that is our interpretation. Or if the price decreases, then we say if the price goes down by 1%, then what about demand? Demand will increase by 0.67%. Okay, so that will be the description of the price elasticity of demand. Now, if you look at the second part, okay, the second part, what we're doing, P equal to 60, and then you get Q equal to 8. So what we got was negative 1.5. So what does it mean? It means that if the price goes up by 1%, then what about the demand? The demand will go down by how much? By 1.5%. Okay? So now when you put in percentage, the unit, then we can make the comparison. Okay? You can compare the elasticity of demand for rice, where the unit is in, say, kilogram, to the demand for petrol, where the unit is liters. Because now the unit that we use will be what? Will be the same, which is what? Which is percentage. So you can make the comparison. If the price of petrol goes up by 1%, the demand will go down by, a certain percentage. So because everything is in percent. So that is one advantage of elasticity. So elasticity, everything is in percentage. So you can make a comparison, all right, for two goods. Now everything is in percentage. For example, let's say you have petrol and rice. Okay, let's say the price elasticity of rice, the price elasticity of demand of rice is equal to negative 10.4. And then the price of petrol, I'm sorry, price elasticity of demand is negative 0.7, say, okay? And then the price elasticity of demand of petrol is, say, negative 10.5. All right, now, I want to describe the price elasticity of demand, which is 10. How do you describe it? So here, okay, petrol liters. Liter. Here, say the unit of the rice is kilogram. Okay, now in terms of price elasticity, we don't interpret it as liter or kilogram. We use what? We use percentage. So how do you describe the price elasticity of petrol? Price elasticity of demand of petrol. The value is negative 10.5. Okay, anybody? Somebody? Cepat lah. Tak apalah, saya tengok apa? Tengok lama. Okay, cepat, somebody. Okay, Daniel. How do you describe the price elasticity of demand for the petrol? The value is negative 10.5. Daniel, are you here? Afiq. Ni Afiq, where is your picture? You know, ni Nurul Alisa, Nur Amirah ni kat mana? Gambar. Put gambar.
Oh, sorry, lupa mau sign in.
Gambar mana pergi? Ni gambar tak ada ni. Berapa gambar lagi tak ada gambar? Ni nak semester dah nak habis dah. Okey, siapa tadi? Tadi siapa saya cakap Daniel. Okey, Daniel. Okey, kalau Daniel tak ada, Syafiq ni. Apa nama? Afiq.
Yeah. Okay.
Go ahead.
The price of petrol is more elastic than the rice.
I know. But now we want to describe what do we mean by elasticity? Before we go into what you said. Describe the value in terms of the price change.
Oh, yeah.
Cepat. Boleh tak apa. Nurul Atikah. Okay, Nurul. Nurul Atikah. Okay, Tengku Diana. How do you describe the price elasticity of demand for the petrol? Cepatlah. I already described a few times.
Sir?
Yeah.
Sir?
Yeah.
If the price increase by 1%,
okay.
The quantity demand for petrol decreased by 10.5%.
Okay, everybody got it? So if the price of petrol goes up by 1%, okay, then what? Then the demand for petrol, okay, the demand will what? Will go down by 10.5%. Okay, so either you can say the price goes up, or if you say the price go down, then the demand will go up. Okay, because of the opposite movement. So that's it. Okay, good. Now, yeah, rice ni macam mana? Rice. Okay, rice, somebody else. Okay, Tengku Diana tu dah cakap bagus dah ini. Okay, so by the same approach. Okay, now, yang price rice, guna-guna, cepat. If the price of rice...
If the price increased by 1%, the demand of rice will decrease by 0.7%.
0.7%, okay, because the unit is in percentage. So if the price of rice goes up by 1%, the demand for rice, I don't put the demand for rice, but it's demand for rice. The demand for rice will go down by how much? By 0.7%. So if you look at these two things, you can make the comparison because everything is in what? In percentage. So you can see here which value is higher. Now, when you make the comparison, okay, when you make the comparison, so here, when you make the comparison, the value is elasticity. We look at the absolute value. We don't look at the value lah. If you look at the negative value, okay, here there are two things here. The two negative. So negative, as you know, which one is larger? 0.7. Okay, negative 0.7 is larger than negative 10.5. Because it's negative. So when we make the comparison, we are going just to look at the magnitude. Okay, the magnitude. So we look at the absolute value. So we just want the magnitude. Okay, you just want the size. So we look at absolute value. What does it mean? It means that absolute value for negative will be positive. So the absolute value for 10.5, we think of it just 10.5. Okay, so when you make the comparison, we don't have to look at the negative sign. So the absolute value for negative 0.7 will be equal to 0.7. Okay, all right. So when you make the comparison, we look at the absolute value. We just want to see the magnitude. So we don't consider that negative sign. So therefore here, which good has higher elasticity, petrol or rice?
Petrol.
Petrol lah. Okay. Like I said here, we don't look at the negative sign. If you look at the negative sign, 0.7 to negative 0.7 bigger than negative 10.5. But when you do this application analysis, we want to look at only the magnitude. So think of it as absolute value. Okay, don't consider the negative number. So here, you say here the value of the elasticity of petrol is higher, and you say that the elasticity for petrol is larger than the elasticity of the rice. Okay, so here negative in terms of absolute value, you got 10.5. Okay, negative 10.5. So absolute value will be just 10.5, which is larger than the absolute value for the elasticity of rice, which is 0.7. So you say that the demand for petrol is more elastic. So you say that if the elasticity of demand for any good is larger than the other, we say that the demand for that good is more elastic. Oh, I forgot the word more. Instead of more. Okay, it will be more elastic. So after we understand this idea, magnitude, you don't have to write in terms of the absolute value. Then you just look at the higher number, get the higher number in terms of positive sign. That will be more, that will be more elastic. You just look at the what, or in other words, we look at the reaction of the demand to the price change. If the demand change by a higher percentage, all right, by a higher percentage, but we know the demand will go down, okay, if the price goes up. But if the reaction, okay, if the reaction of the demand is by higher percentage than the other good, then you say that it's more elastic. Okay, all right. Any question about that? It's more elastic. So when you look at this thing here, we can categorize the elasticity, the categories of elasticities. Okay, categories of elasticity. If the absolute value of the elasticity is between 0 and 1, we call it inelastic. If the elasticity is bigger than 1, we call it elastic. Okay, now why inelastic? Because if you look at the example rise, the reaction, okay, the responsiveness of the demand, okay, toward 1% increase in the price is smaller than 1%. Price increased by 1%, right? But the demand will go down by only what? By only 0.7%, which is less than 1. So we call it inelastic. On the other hand, if you look at the petrol, if the look at how the demand responds to the price increase, will be higher than 1%. Okay, the response of the demand is what? Is 10.5%, which is larger than what? Which is larger than the increase in the price, which is 1%. So we categorize it by this category: elasticity absolute value bigger than 1, elastic. Elasticity in absolute value less than 1 between 0, bigger than 0, less than 1 will be called inelastic. Right. Okay, so for the rise, you know, the elasticity is what? Negative 0.7. So negative 0.7 absolute value will be what? Will be here. So that will be inelastic. Inelastic. Elastic, the demand for the petrol, the value is negative 10.5. So absolute value bigger than 1, we call it elastic. Okay. So you can see here the demand for petrol is more responsive to the price change. So you can see here the demand for petrol, okay, demand for petrol more responsive, more sensitive, more responsive to price change. Okay, if the price goes up by 1%, the demand for petrol is quite responsive. They will go down by 10.5%. You know, but for rice, it's what? It's less responsive. The demand for rice will just go down by 0.7% if for a given price increase by 1%. Okay, all right. Now, what does it imply? Now, if you relate from what you learn in economics, if the demand in inelastic, what does it mean? What does it imply? Or you can put the other way around. If the demand is inelastic, or you know, what categories of good normally the demand
inferior goods.
Inferior good. Is it inferior good?
Oh, yan
I think you it's not inferior good. Inferior good is something like inferior good is something that if you have more income, your demand for that good will be lower. That is inferior good. Okay, macam Maggi ya, Maggi. If you have more income, then the demand for Maggi will be lower lah, because you eat other food. So that is inferior. Inferior is related to income. But if you are looking at the price elasticity of demand, well, it's another type of good, you know, where the demand is inelastic, like rice. You know, if you look at rice, for our case, is rice inferior good? Rice is not inferior. Okay. What kind of good is rice?
Normal good.
Normal good. Okay, it's a normal good, and it is what? It is necessity. Okay, it's necessity. If you look at the necessity good, the basic need, the one that we need for basic need. For us, in Malaysia, or people in LCR, rice, huh? But if you look at people in India, they don't eat rice that much. They eat bread, okay? Or you go to Arab countries, they also eat bread. So the necessity good, the basic need for different culture are different. So for us, rice. So if you see here, the elasticity of rice is normally inelastic because it is necessity. Right? Even the price goes up, you still have to buy the rice. Right? That's why the elasticity is very low. We call low than one, less than one. On the other hand, petrol is not necessity. Okay, petrol is not a basic necessity for us. If the price goes up of petrol, by 1%, we are quite responsive. The demand for petrol will go down by what? By more than 1%. Yeah, by 10.5%. Because when the petrol price goes up, we consume less petrol. You go for less traveling, or you ride bus, or you ride bicycle. So because there are so many options. But for rice, if the rice goes up, what do you eat? Can you eat bread for 5 days consecutively? I mean, I'm talking about Malaysian. Can you eat rice 5 days consecutively without rice? To me, I cannot. Okay, I cannot survive. I need to eat rice for 5 days. You cannot just eat bread. So normally the necessity good would have the inelastic demand. That means the price elastic demand will be less than 1. Okay, less than 1, between 0 and 1. Okay, all right. So we already see that example. One is petrol. Petrol is not elastic, but rice will be elastic. Okay, any question? Anything? Kita ni chapter apa ya? Ada satu lagi tu. There is another thing that I would like to look at. Remember when we were talking about that thing? The elasticity and revenue. Elasticity and revenue. That will be the last part of chapter berapa? Chapter berapa benda ni? Ni dah, ya. I got it. Chapter 11.5. So that is on the elasticity. Okay, elastic, inelastic. So you don't have to worry about the unitary elasticity. Itu tak payah. All right. So we only worry about that thing. Okay. So the next part is you want to look at the elasticity and revenue. Elasticity and revenue. You want to look at the relationship between the revenue and the elasticity. Okay, dia macam ni. Alright. How does it relate? Do we want to do that? No, it's already 10:23. I think tak payahlah. Tapi this one is quite practical, Actually, we can learn quite a lot from this. Okay. Here, elasticity and revenue. We will just do quickly. Elasticity and revenue. Now we know your revenue is equal to P times Q. That means how much you get by selling the good. All right, by selling the good, you will get. I mean, you will sell a certain amount, certain quantity at the price, so you get your revenue. So the revenue would change to two things here. One is the price change. Okay, if the price change, you change the revenue. And there is another factor here, the change in the queue. All right, change in the queue also increase your revenue. Okay, next. Our purpose is, I want to increase revenue. People we want to earn more revenue. Okay, now how do you get more revenue? How do
Increase
you
the
get?
quantity.
Huh?
Increase the quantity.
Either you increase the quantity or you increase the price. All right, but normally the one that you have control on is you increase your price. Okay, if I want to increase revenue, I will increase price. All right, now when you increase price, the effect will be on the quantity. So that's where the change also in quantity will be also important. If you increase your price, all right, what about the quantity?
Decrease.
If you increase the price, consumers will buy less. Okay, because the demand function. Okay, that's the demand. If you increase your price, the demand will be down. All right. So delta Q would be what? Will be going down. Okay. So now what you need here is you want to balance up. Okay, you want to balance up the increase in the price and the decrease in the quantity, so that your revenue will go up. So you have to balance up. If your increase in the price is less than the decrease in the quantity, then what about your revenue? Your revenue will go down. Okay, your revenue can go down. So you need to balance up this thing here, so that the revenue will continue to go up, not go down. Okay, so here if the price goes up and quantity decrease is too much, then what happened? Your revenue can go down. Okay, on the other hand, okay, by the same token, we can also argue that if you want to increase your revenue, what can I do? I can decrease my price. If I decrease my price, what about the quantity?
Increase.
Quantity will go up. Okay, so again here I need to balance up. If I reduce my price, which is the down pull, okay, the pull downward to the revenue, but quantity will go up. So I need to balance up also. Okay, if I reduce my price, I need to balance up with the increase in revenue, so that my revenue will continue to rise. Okay, so it doesn't mean that if you increase your price, your revenue will always goes up. Not necessary. Why? Because there is a change in the quantity. Okay, and sometimes it may be worth. All right, rather than you increase your price, what do? We reduce the price. Okay, so that the quantity will go up. If the quantity is going up by much higher magnitude, then what happened to revenue? Revenue will go up. So, having understanding or having said that, the relationship between the increase in the price and the change in the quantity, which affect revenue. So you want to relate to elasticity. Okay, you want to relate to elasticity. Now, what is elasticity? Elasticity is the percentage change in the quantity in the demand divided by percentage change in the price. All right. Now, if let's say if I put here for the petrol, for the petrol, the price increased by 1%, but your demand will go down by how much? go down by 10.5%. So now, which effect is higher? The reduction in the quantity or the increase in the price?
Reduction in quantity.
Reduction in the quantity, 10%. You increase your price by 1%, you know, the demand will go down by 10%. So your revenue, what? Your revenue will go down, okay? Because the percentage decrease in the quantity will be higher than what? Then the percentage increase in the price. So here, the quantity decrease, which is equal to 10%, 10.5%, that is bigger than what? Then bigger than the price increase, which is by only 1%. What happened to your revenue? Revenue may go down. Okay? All right. On the other hand, if we reduce the price by 1%, then what about the demand? If I reduce the price 1% of petrol, what about the demand?
Oh, the demand will increase.
The demand, betul. The demand will increase by 10%. Okay? So here, what happened? So here you see the quantity increase, okay, which is equal to 10%, 10.5%, is larger than the reduction in the price, which is 1%. So the positive effect, okay, the increase in the quantity will push the revenue up. The decrease in the price will push revenue down. But now, the push upward, okay, since the quantity increase or the demand will increase by 10%, 10.5%, which is higher than 1%, the increase in the price, what happened to your revenue? Revenue will what? Revenue will increase. So therefore, for this kind of good, which one is better for us? To increase price or reduce the price?
Reduce the price.
Reduce the price. Okay, you decrease the price by 1%, your demand will be higher by more than 1%. So that's good for you. So what we are saying here is this. It's not necessary that you will want to reduce you want to increase your price. All right. Sometimes it is good to reduce your price. By reducing your price, that will be what? That will be offset by the higher demand. And your revenue will go up. Because revenue does not depend only on the price, on the price change, I'm sorry. It will also depend on what? On the quantity change. Okay? All right. So that is how the effect, okay? The effect of elasticity on revenue. I don't intend to cover too much, you know, because I need to talk about the Lagrangian. But from this is more intuition, okay? It's more of intuition. We relate revenue to the elasticity. Okay, all right. So now I want you to do this. Okay, I want you to spend a few minutes looking at another good. Okay, looking at another good. Suppose the good here is rice. Rice. I think for us to look at the thing better, we reduce the value of the elasticity. Okay. Now suppose we look at rice again. We know that price is the demand is inelastic. Tapi now suppose the because I want to show, you know, to show it clearly. Let's say negative 0.2. Kita tuangkan. Okay, negative 0.2. So negative 0.2. So now I want you to relate the elasticity to revenue. Okay, to revenue. Macam tadi lah, macam kita buat on the rice, on the petrol. Alright, so negative 0.2, you relate the elasticity to the revenue. Okay, equal to P times Q. So ingatlah, okay, the price, the revenue can change due to the change in the price, and also due to the change in the Q. And they are moving opposite direction. Okay, price goes up, the quantity change will go down, and that will affect your revenue. Okay, all right. So this one I will ask you to do, but this is not very important. Okay, the part revenue to the elasticity to not so important. So if you don't really focus on this one, that's fine. But what is more important is this thing here. All right, the computation of the elasticity. Because I just cover this very briefly, and probably some people, may not get it. So that's fine. Okay, now the homework itu saya dah lupa lah. So the homework number 2, okay, homework number 2, the group homework number 2, the deadline, I want you to submit by tomorrow. So you submit tomorrow, don't submit today, okay? Because I post the question in the classroom tonight, okay? Tonight or tomorrow morning. So you submit tomorrow by 5 p.m. Okay? So that is. Sini, dia lagi sini. Okay, so that is the homework number 2. We submit by tomorrow, 5 p.m. Okay, any question, anything with regard to the elasticity? Okay, good. All right. Now, what I want to do next is we want to go on or go up to the next part that I did not cover earlier. We go to 14.5. The 14.5 is on the partial derivative related to the maximum and minimum. And here you have the optimization problem. So we are solving optimization problem. Just similar to the linear programming, okay, optimization problem. And we are looking here at a method which is called the Lagrangian method, Lagrangian multiplier. So the method is Lagrangian multiplier method. The problem is optimization problem. Now, when you have optimization problem, it's like the linear programming problem. You have what? I have an objective that I want to maximize or minimize, and that objective is maximized or minimized subject to a certain constraint. So that is optimization. You maximize subject to constraint. So here, you want to maximize an objective function. Okay, an objective function. Subject to what? Subject to some constraint. Subject to some constraint. Now, if you recall, in the linear programming topic, our objective that you want to maximize or minimize is a linear function. All right. And then the constraints are what? Inequalities. All right. In this part, you have objective function, a function. The constraint is also a function. So here both are functions. So we don't deal with inequalities lah. We deal with function. Objective itu memang function lah. Alright. The constraint too is also a function. So you have what? You have maximize an objective function subject to some constraint. When I say some constraint, that means not many constraints. Actually, some constraint mean only one constraint. Okay, it's a constraint. And of course, our problem can also be minimized. So it can be maximized, it can be minimized. Right? Okay, example. Okay, example again here in what? In economics. What is the problem of the consumer? You know consumer? Okay. In the consumer theory, what do we maximize?
Satisfaction.
Satisfaction. But you cannot. You don't want to. You cannot maximize your satisfaction unlimitedly. Okay? What is our limitation? Our limitation is what? The constraint. What is your constraint? Resources constraint. Okay, you have a resource constraint, which is what? Which is our income. Okay, of course, everybody wants to maximize utility, satisfaction, but you cannot maximize it indefinitely. You have to consider your income. Okay, so consumer problem is that we maximize utility. Okay, we call it utility, the satisfaction, but we do it subject to income constraint. So, all right. So you have a constraint, and then you have something that you want to maximize. So that is one example. Now, how do you solve that problem? Okay, here we are going to solve it by using the multiplier or by the Lagrangian multiplier method. So let me summarize or let me state the problem. Okay, our problem will be to maximize. I will start with maximize, then we put minimize because everything is the same. Maximize the function z equal to f of x, y. That is our objective. Okay, subject to the constraint. Subject to the constraint, which is another function. We call it dxy equal to k, where k is constant. So where k is a constant, that means the limited resources. Okay, that is the limitation. We cannot go beyond that constant. Okay, that is our limit. For example, income. All right, your income per month is limited. Okay, if you have unlimited income, then like macam Bill Gates, he has unlimited income. Or people, Alibaba, the owner of the Alibaba, Jack Ma. Okay, so you have income limited. Say 500 a week. All right, 500 per week. So that is our limit. You want to make sure that you will spend to your highest satisfaction given that amount of money. So that's where how you manage, how you manage your budget. So how do you do that? We just look at what you want to maximize your satisfaction that you get from the different goods. So here, that's that kind of problem. Or we can look at minimize. It's either minimize or maximize. Okay, so you have here two functions. One is the objective, one is the constraint. So the method that we're going to solve is you want to find, all right, maximize, minimize. So in other words, you want to find the optimum combination of X and Y. Optimum combination of X, Y. Okay, we call it X star, Y star. That's like equilibrium. Okay, X star, Y star. That maximize your utility. I'm sorry, not utility example. That maximize your objective given the constraint. So I want to find the optimum combination of X, Y, call it X star, Y star, that maximize the objective, JB, objective given the constraint. So that's why you call it optimum. Okay, optimum, that means the best that you can do given the constraint. So here you maximize. If the problem is minimizing, then it's minimized. All right. Okay, you want to find the optimum point. So now I put down the problem. So in order to solve this, we are going to use the Lagrangian method. Now, what is Lagrangian method? Lagrangian method is simple. What you do here, you will combine. We will combine the objective, okay, and the constraint into one function by introducing another variable, and that variable you call it multiplier. So that function that you have at the end, we call it Lagrangian function. So you define your Lagrangian function. Lagrangian function. We denote by L, okay? And that L is a function of X, Y, and lambda. That lambda is the multiplier, which I will touch a little bit afterwards. That will be equal to the objective, f of xy, plus, all right? We introduce the lambda, okay, which is a new variable, we call it multiplier, multiplied by the constraint. Now, the constraint, we will have to write in this form. Oh, ditukar hitam pula dah. D x y minus k. Okay. So that is our function. So what I said earlier, you combine, okay? You combine the objective, yeah, with the constraints, forming one function. By what? By introducing the multiplier. So that thing, alpha lambda, yeah, is the multiplier. And it is a variable, okay? The multiplier to variable, okay? It's a multiplier. And it's a variable. So you have the Lagrangian, the L, function now of 3 variables. Okay, all right. The other one is you have the constraint g of xy equal to k. What you do here, you just bring the k to the left. So you have g of xy minus k equal 0. So that left hand side you write in the left function. So that would be our Lagrangian function. Now, how do you solve this? Okay, how do you solve it? It's just like we're doing the partial derivative. Okay, for partial derivative, what first do we do? Because if you want to maximize the function, you know, using the partial derivative, first thing that you do, what do we do? Before you know the function has a maximum or minimum at a certain point, you find the critical point. So similarly here, you find the critical point. All right, the critical point is by looking at the first partial derivative. So you're looking at the first partial derivative. We call it first order condition. First order ini first partial derivative lah. People sometimes call it FOC. FOC ini first order. First order means first partial. First order, second order. Second order itu second derivative. First partial derivative condition. So short form, first order. So like I said here, we're looking at the first partial derivatives. In short, we call it FOC, first order conditions. So what you need here is, since there are three variables, I need to differentiate the L with respect to X. All right, and then I need to differentiate L with respect to Y, and then I need to differentiate L with respect to lambda. So here there are three partial derivatives. Okay, back to the function. You have f of xy, you know, the function f depend on x and y, and then the constraint g also depend on x and y. So what you need here, you look at the functions, the function L, and what is the partial derivative of L with respect to x. Okay, this is it. You got f of xy, since the f depending on x and y, so I have to differentiate f with respect to x, just call it fx, plus I got g inside the lambda, okay, with that depend on x, but it's multiplied by the lambda, so I got lambda g of x. All right, okay. Now ly, you take derivative of f with respect to y, I got fy plus the lambda multiplied by g, I take derivative with respect to y. So gy. All right. And there is another variable, lambda. I take the derivative of L with respect to lambda. I have a lambda here. Okay. Now, if we differentiate with respect to lambda, what do I get?
Lambda dx.
I got the lambda dx, not lambda dx. If lambda now is the variable. Okay, the lambda here is the variable. It's just lambda. It's not lambda squared or lambda whatever. It's just lambda. So if I differentiate the L with respect to lambda, what do I get?
0.
No, kata lambda. Okay, I got y equal to lambda. Okay, that lambda is just lambda. So what is dy d lambda?
1.
1. Okay, 1. So this is equal to 1. Now 1 multiplied by everything in the bracket, because it is multiplied by gx y minus k. So therefore, the derivative with respect to lambda will be equal to the things in the bracket. Gxy minus k. Because the lambda is multiplied by everything in the bracket. All right? You differentiate with respect to lambda, I got 1. Okay, so you relate to L. So in other words, if you put L, okay, I the idea it's Y, but probably it's good that you use the lambda. Ketika lambda, ketika L equal to lambda. So you got dl d lambda equal to 1. Okay, but here you got 1 multiplied by everything in the bracket. Okay, so that is the derivative with respect to lambda of L. Now for critical point, everything must set be to 0. So that is for critical point. And here you have 3 equations. 1, 2, 3. So for the partial derivative, you have 2 equations. You have fx, fy. You have 2. Then you solve the 2, you got the critical point. Here we have 3 variables. So therefore, we have 3 equations. 3 variables, 3 equations, you can solve it. So you make use of the 3, you will find the point x star, y star, and lambda star. But for us, we don't need the lambda. Okay, we do the lambda. Of course, you can find the lambda, but we don't need lambda. I only need x star, y star. Okay, we need only x star, y star. We don't need the lambda. So we're going to make use of the 1, 2, 3 in order for you to get the optimum point. All right. Okay, now how do we do it? Okay, this is the method. Okay, the method is, okay, are you done? Are you done here? Are you done with the partial derivative? Dah siap ke belum? Okay, if you are not done, I will wait. If you have done, I will move on. Dah siap ke belum? Hello? Finish?
Dah.
Okay, dah.
Okay.
Okay, good. Okay, kalau tak siap, I want you to write this because you know that's how the method is. So you got to have this. So you have 1, 2, 3. All right. How do you find the x star, y star? So number 1, we make use of the 1 and 2. Okay, so 1 and 2, we do 1 and 2 first. You got 1 and 2. What we do, you write lambda equal to what? If you got from 1, okay, from 1, if you bring everything to the right, just keep lambda to the left, at the left, what do I get? Lambda equals what? Okay, cepat. You got lambda plus g. No, I got fx plus lambda gx equals 0. Now I want to bring everything to the right except lambda. So that lambda will be in terms of the fx dx. So what happened? Lambda is equal to what? Okay, you do it now. You bring the f and g to the right. Lambda is equal to what? Okay, from 1 and 2. Okay, from 1 and 2 lah. Tapi sini 1 dulu. Okay, from 1. So lambda equal to what? Cepat. Just look at the equation number 1. Lambda is equal to
negative x divided by
negative x.
Fx.
fx.
Negative fx divided by
Gx.
gx. All right. Similarly, from number 2, I got lambda equal to what? Negative fy over gy. Now here you got lambda and lambda equal to, so therefore, what? What is the next step?
Equal.
Oh yeah, equal.
1 and 2.
1 and 2, they are equal. Okay, so therefore, negative fx over gx is equal to negative fy over gy. So positive, negative, and positive, negative become positive. So now, by equating this thing, because they are equal, lambda tu dah tak ada. Okay, you don't have lambda anymore. What you have is fx, gx, fy, gy. So what we do here, okay, what you got from here, you will write x in terms of y. So x in terms of y, x as a function of y. Or you can write y in terms of x, doesn't matter. And then once you got x in terms of y or y in terms of x, we substitute into what? Substitute into number 3. Okay, so into number 3, you have g of x minus the constant equal to 0. So you can solve for x and y. So substitute into number 3, I will get x star, y star. Okay, all right, so that is the general method. Okay, that's the general method. From 1, you write lambda in terms of the x and y. That means negative fx divided by gx. From number 2, I have the lambda equal to, or I write lambda in terms of y and x. We have negative fy over gy, and they are both equal. So therefore, fx over gx is equal to fy over gy. So lambda is no more, correct? We have only x and y. So you can write x in terms of y or y in terms of x. And then you substitute that into 3, we can solve for x and y. So here what I mean by substitute, we substitute, okay, either one of these. Okay, you got it? Okay, that's the general method. So in order to get a better idea, we do an example. So let's consider one example. Mana example? Okay, example number 1. We're going to look at a few examples. Example number 1. Suppose you want to maximize f of xy equal to 25 minus x squared minus y squared. Subject to. Okay, now subject to, I use short form ST. Subject to 2x plus 3y equal to 50. So that's the constraint. See here, the constraint is equal to a constant, and that is 50. Okay? All right. So now how do you solve it? I want to maximize. I want to find. All right. In other words, I want to find x star, y star. That solves the problem. Okay. That solves the problem here. So what do? We use the Lagrangian method. So you define the Lagrangian. What you know, the Lagrangian is equal to what? F of xy plus lambda g of xy minus k. So we know that is the form. All right, that's the general form. Now we put in the specific functions. The objective is equal to what? The objective is equal to the 25 minus x squared minus y squared. So 25 minus x squared minus y squared. So better put bracket lah, so that indicate that is the objective. Plus lambda gxy minus k. So now what you need to do here is, from the constraint that is given here, you just rewrite. Okay, so 2x plus 3y equal 50. We write it in form of 2x plus 3y minus 50 equal 0. So this is the one that we put into the Lagrangian. So multiplied by lambda, 2x plus 3y minus 50. Okay, satu lagi. Dah dapat L. Okay, you dapat L, what do? We take the first partial derivative. We call it FOC. Ingat FOC, free of charge. Okay, ingat tu je, free of charge, FOC. So what are they? They are Lx. Okay, Lx, derivative of L with respect to x. What do we get? You get here x squared. Sini ada x. Sini pun ada x. So the first one, what do I get? I get negative 2x, which is fx lah. Okay, if you go back to the concept, that is fx. And then we need to look at the lambda, which is the variable multiplied by the derivative of g. Now, what is the derivative of g with respect to x? Gx is what? What is gx? Berapa?
2x. So 2.
2, bukan 2x, 2. Okay? 2. But the 2x multiplied by lambda, lambda 2 equal 0 or 2 lambda. So we go back to the formula. You know, you go back to the formula. It's lambda multiplied by dx. Okay. So lambda multiplied dx. So don't forget the lambda. Okay. The lambda is multiplied to the d of x. So think of it as what? As the coefficient of the 2x. So lambda is a variable, all right? But lambda is a variable. Or one way to think of it, that it can help, you know, to get the idea, you multiply out, okay? You multiply out dulu, siap. So here you got lambda 2x plus lambda 3y minus lambda 50. Okay, you can do that also, just to make sure that we are not going to mix up. Okay, sometimes you may confuse when you do the derivative of the second part, the constraint. Sometimes you throw out the lambda, you just say 2, no, which is not right. So one way to reduce the problem, you multiply out everything. Okay, so if you can look here, you got lambda 2x. Differentiate with respect to x. What do I get? I get lambda times 2. Okay, so lambda 2. Or you can put 2 lambda. Boleh juga? Betul sikit, lambda 2 lambda. But I maintain the lambda 2 because I want to just be consistent with the rule, with the formula. But you can write 2 lambda. That's fine. Okay, secondly, you get the Ly. Ly berapa dapat? Ly? Ly berapa? Take derivative with respect to y now. What do I get?
Negative 2y.
Negative 2y plus lambda berapa?
Lambda
3 lambda. Lambda 3. Okay. So that is our number 1, number 2. Okay. Now number 3, I don't have space there, so I put as ini. Okay. L lambda. Okay. L lambda. You differentiate everything with respect to lambda. So first, the f of xy tak ada lambda. Okay, no lambda. So you only look at the second part. So what is the derivative with respect to lambda? You see here, 2x plus 3y minus 50. Or if you go back to the formula, it's just gx, y minus k equal to 0. And that is our number 3. Now, one way to look at it, or, you know, just to avoid doing mistake, you do the second part, like I did here. Okay, so first term, differentiate with respect to lambda, what do I get? I get 2x. Second term, differentiate with respect to lambda, I get what? I get 3y. The third term, I differentiate with respect to lambda, I got 50. So, or you can do it right away. Lambda multiplied by g of x, everything in the bracket, so that will be equal to g of x. 2x plus 3y minus 50. Okay, any question? Okay, now I want you to try do this. You use 1 and 2, you know, like what I said, the general method, and then you get x in terms of y or y in terms of x, and then substitute into number 3. So you can find the optimum point. Okay, so do it now. Get the point. Okay. You got it? Tadi dia putus dah. Hello? Can you see the thing?
Not yet, belum lagi.
Okay. Dia terputus tadi. Saya tak perasan. So now I got to share screen balik. Okay, now can you see? Boleh nampak?
Okay, nampak.
Sound boleh dengar? Saya punya voice boleh dengar? Okay, good. So now kita tengok balik. So here what you have is this thing here. So what is our solution? So you will see here. Okay, so what you do, from number 1, what do you get? So from 1, we follow the method. From number 1, you got lambda equal to negative. Negative 2x kan? Negative 2x you bring to the other side, that will be equal to, tak adalah negative. Okay, you bring a negative 2x, so that will be 2x. Okay, 2x and divided by
2.
Okay, we can put, or if you look at this one, that means 2 lambda, okay, equal to 2x. Therefore, lambda is equal to 2x over 2, which is equal to x. So that is okay. From number 2, your lambda is equal to negative 2y, so 2y. So here I will do here 2y. You have 3 lambda. 3 lambda is equal to 2y. Okay, so our lambda is equal to 2 over 3y. Okay. So here you see lambda equal to x. Lambda equal to 2 over 3y. So therefore, x is equal to 2 over 3y. Or you can write y equal to 3 over 2x. Doesn't matter. Okay, you can do either way. Right? Okay. So what you have now, lambda dah tak ada. Alright, lambda is gone. So we can put this into what? Into number 3. So you substitute x equal to 2 over 3y into 3. So what do I get? I get 2x. So that is our equation. 2x plus what tadi? Plus 3y minus 50 equal 0. So that is G lambda. Oh, not G lambda, L lambda. Okay, L lambda. 2x plus 3y minus 50 equals 0. So now that is equal to 2 over 3 y plus 3y equal 50. You see here, everything now is y in terms of y. So you can solve for the x and y. Okay, for the y lah. Betul ke ni? Y equal to 2 over 3 y, betul? X equal lambda is 2 over 3 y. Betul ya? Okay. So that is 4/3y plus 3y equal 50. Okay, so 4/3y, so you will have 3y, 9 plus 4, 13. So you got 13/3y equal 50, and y equal to 350 divided by 13. Berapa value dah? Okay, 150/13. Berapa dapat? 150/13. Siapa ada calculator boleh?
11.54.
11.54. Itu dia. Okay, so that is the value of y. So that is y star lah. Okay, so we can put here that is our y star, which is 11.54. Now next, I want to find the value of x. So to find x, what do we do? To find x, we substitute lagi sekali. Okay, now substitute into what? What is the easiest equation that you can substitute into? Substitute into what?
X equals to 2/3y.
Masuk 2/3y. So 2/3y, kita tulislah y itu dulu. Okay, like I said, it is better to write more step than less step. Equal to 2/3y, that is equal to 2/3 multiplied by 11.54. Dapatlah. Okay. Apa dia kata itu, dapat value dia, berapa dapat?
7.69.
7.69.
69.
69. Okay. 7.69. So that is our solution. So to maximize, all right, to maximize the objective subject to our constraint, the optimum point is x star equal to 7.69, y star equal to 11.54. Okay, so that is our first example. Okay, I give you another example. Okay, tengok dulu tengok kat buku ada example apa dia bagi. Okay, so we look at the second example. Now, example number 2. Okay, I have a few more minutes. So example 2, let's say you want to minimize the objective f of xy equal to x y squared. Kita tambah constant satu. 5 x y squared. Subject to the constraint x. Apa semua file ni? Okay, subject to 4x plus 7y equal to 8. Okay, so what I want you to do, I want you to set up the Lagrangian. All right, write down the Lagrangian. Okay, do it now. Write down the Lagrangian. So remember, Lagrangian is the objective plus lambda multiplied by the constraint. The constant you bring to the same side, or you rewrite the constraint as equal to 0. Okay, now once you get the Lagrangian, okay, I want you to try get the first partial derivative. Putri Rashidah, Putri Rashidah, are you here? Hello, Putri Rashidah, are you here or you're not here? Sekarang ni dah balik kampus ke ataupun masih dekat kampung? Baik, mana pergi budak ni? Tidur ke apa? Ada. Ni. Okay. Did you get the Lagrangian?
Yes.
Okay, good. So what is the Lagrangian? So the Lagrangian, you put down the objective. All right, you put down the objective, and then plus the lambda multiplied by the constraint. All right. So the Lagrangian is equal to 5xy squared. Okay, so you write down the first. Okay, you write down the first part. F of xy plus lambda gxy minus k. You write down. I don't have lah. Plus lambda multiplied by 4x plus 7y minus 80. So the constraint, okay, you rewrite, you bring the constant to the other side, so you got it. Okay, all right, good. So now you got the first order conditions. You got Lx, Ly, L lambda. So I want you to, if you have time, I think you have time, over the weekend, you finish this up. Okay, you get the first derivative. I mean, you do the first partial, and then you try to solve for the optimum form. And then I will continue from here. Okay, I will continue next. So try to do this. Okay. I think I will stop here because our time is up. Remember the homework, okay? Submit the homework on time. Anybody submit late than that, I will not accept. And make sure, okay, for those people whose name is not yet adjusted according to the list, please make the change. And then I want you also to submit like the first homework. That means the person who submitted the first homework, submit the second one, so that the order will be the same, okay? So that the order will be the same. It's easier for me to grade the homework according to your group. Okay, all right. Any question? Kalau tak faham, sila tanya. Don't make the mistake, all right? Some people, they don't want to ask. They just hentam promo, and then you do as not as instructed. So susah. All right. So
Sir.
yeah.
Sir.
Yeah.
Contoh example. If in homework one, it was I who submit the homework to you. So for the second, me lah kan yang hantar lagi.
That means you will submit, but the person who write must be different. Let's say you write the first one, your partner now write the second one, but submit will be you, so that the order will be the same. Okay, so you maintain the order of your name as per the first homework. Okay, so what you said is correct.
Alright.
Betul? Okay, so that the order sama, so that easier saya nak grade. Kalau because I'm not sure. Okay, I'm not sure about this computer thing. I'm not sure about this. All right, because I'm not very expert menatang ni. Susah sikit. Because if another person send, then the order will be different. Okay, the order will be different for your group. Then I have to spend a little more time lah. Okay, so if the first person send, that means the order will be the same as the one before. Then easier for me to locate your group, because your group, I arrange it in the order of like the first homework. Macam tu dia. Okay, I think, so to make things easy, so senang if the same person do the submission. Okay, all right. So understood, Okay, good. So I will see you again next week. So next week on Monday, we will discuss the midterm and then see, how much we can cover on the matrix. So I will see you again. Have a nice time study. Okay, now you can start study for the final. You have 2 more weeks. Don't wait until the last minute to study. Mathematics is not something that you can study last minute. Mathematics is something that you need to study all the time. You have to be consistent. Istiqomah, tahu istiqomah, consistent. You don't have to spend 3 hours a day. You can spend half hour a day, but doing it every day. Okay, you don't have to do 3 hours a day, but forget it for 2 weeks and then do another thing in 2 weeks time. That is not the way. Okay, it's not efficient. The smart way is mathematics. You do it every day or every 2 days, whatever your schedule is, but make it often. It can be what? It can be shorter period of time. You don't have to spend too much time. Because mathematics ni sebenarnya senang ya. It's just a system. Okay, you don't have to remember any dates. You just remember the formula, and then the formula, the one sometimes, when you do the question many times, you remember the formula. The formula is not that difficult to remember. Some lah. But the formula that I want you to remember pun ya senang-senang Kalau susah tu tak payah. Okay, alright. So I will see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Thank you,
Thank you,
sir.
sir.
Waalaikumsalam warahmatullahi
Okay.
Thank
Thank you.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you. I'll see you again.